The optic nerve is the second of 12 cranial nerves which carries our sense of sight. In this mnemonic video, we'll give you an easy way to remember all the important facts about the optic nerve. Let's get started. For those of us with bad eyesight, glasses are an absolute necessity. Today, we've stopped by an optical shop to purchase a brand new pair of glasses. This optical shop is our symbol for the optic nerve. Get it? An optical shop for the optic nerve? I look pretty slick in these new glasses. So slick that I've asked the shop owner to snap a quick picture. And of course, no photo is complete without a peace sign. By the way, my 2 fingers raised up in this peace sign is our symbol for cranial nerve number 2. Get it? Because the peace sign is made by holding up 2 fingers. The optic nerve is cranial nerve number 2. Remembering what number goes with what cranial nerve is crucial, so use this peace sign in the optic shop to remember that the optic nerve is cranial nerve 2. With the name and numbering out of the way, let's move on to what kind of information this nerve carries. In order to make sure that these glasses fit perfectly on my face, the optician is using a fancy sensor to measure the fit. By the way, a sensor is our recurring symbol for sensory information. Get it? Sensor for sensory? The optic nerve is a sensory nerve, which means that it transmits sensory information from our body to our brain. Sensory nerves are also called afferent nerves, which is just a fancy way of saying that the signal travels to the brain rather than away from it. In this case, the optic nerve transmits signals from our eyes to our brain. Hung up on the wall of every optical shop, you'll see eye charts with all of those letters in decreasing sizes. This eye chart is our symbol for vision and sight, since the chart is used to measure your vision. The optic nerve functions to transmit our sense of sight. It transmits visual information captured from the retinas of our eyes to our brain for processing. Specifically, the visual information originates from retinal ganglion cells, which collect the light information captured by the back of our eye and transmit it into the optic nerve to reach the brain. With the function nailed down, let's move to discuss the path the visual information takes to get from our eye to the brain. From the retina, the optic nerve from each eye travels to enter our skull through a cranial foramen, or opening, located at the back of our eye socket. This cranial foramen is called the optic canal. We didn't symbolize this name here since it should be obvious that the optic nerve travels through the optic canal. I mean, come on, it's right in the name, folks. After passing through this optic canal, the nerve is technically inside our brain. Once in the brain, the optic nerve from each eye actually comes together at a crossover point called the optic chiasm, before traveling to the thalamus, where the signal is relayed to eventually reach the primary visual cortex for processing. I know we rushed through this. The details of the optic tract are actually so complicated and so interesting that we're going to make a whole other video dedicated to the topic. We're actually pretty interested in vision after all here at Pixarize. Keep an eye out for that one. Next, let's review 2 important reflexes that the optic nerve plays a role in. While fumbling around with his camera, the photographer accidentally set off the crazy bright flash. Naturally, I reflexively squinted my eyes in response to the flash. The squinting eyes is our symbol for the pupillary light reflex, because I'm constricting my eyes in response to the bright flash, just like how the pupillary light reflex describes the constriction of pupils in response to light. The optic nerve is a crucial component of the pupillary light reflex, which, as we mentioned earlier, causes your pupils to constrict in response to light. To be more accurate, the optic nerve controls the afferent, or sensory component of this reflex. It sends a signal to the brain that there is too much light entering the eye. Afterwards, a different nerve, the oculomotor nerve, or cranial nerve 3, kicks in to actually deliver the motor signal to constrict the muscles around the pupils. Despite the role of both nerves in this reflex, there is a big difference between the pupillary light reflex mediated by the optic nerve and the oculomotor nerve. Let's talk about what that is. That flash was so bright that I couldn't help but squint both eyes. Squinting both eyes should help you remember that signals in the optic nerve controls the pupillary reflex for both eyes. This is to say that if I shine a bright light into just one of your eyes, both of your eyes should constrict equally, even the other eye. This is important to remember because damage to the optic nerve will result in the loss of constriction in both eyes. The technical name for this is consensual reflex loss. This differs from the oculomotor nerve, which controls the motor input to only one eye at a time. Therefore, damage to the oculomotor nerve results in one-sided reflex loss, while damage to the optic nerve affects the pupillary reflex in both eyes. Got that? Why did the photographer set off his flash in the first place? Well, it looks like he was trying to adjust the camera lens so that it would focus to get a clear picture of my face. Adjusting the camera lens is our symbol for the accommodation reflex, because the accommodation reflex allows our eyes to focus on close objects, just like how this cameraman is adjusting his lens to focus on my face. The optic nerve also is an integral part of the accommodation reflex. Here, it also controls the afferent or sensory component. You see, if the optic nerve transmits an unfocused image to the brain will respond by sending back motor signals down a different nerve, again, the oculomotor nerve, in order to adjust the lens of the eye and achieve a focused image. This role in the accommodation reflex should be pretty easy to remember given that you need inbound visual signals to know when to focus. Got that? Alright, that's it for the optic nerve. Let's summarize what we've learned here. The optic nerve, also called cranial nerve number 2 or the second cranial nerve, is a sensory nerve that transmits our sense of sight or vision to the brain. The nerve originates from retinal ganglion cells in the back of our eye and travels through the optic canal in the skull to enter the brain. As the sensory component of vision, the optic nerve plays major roles in the sensory components of the pupillary light reflex in both eyes, as well as the accommodation reflex. Okay, now we're actually done. With this new pair of glasses, I can see your future sky-high test scores as clear as day. I'll see you in the next one.